Hey guys, welcome back. Today we're looking at 5.5 properties of logs. So the properties of logs come directly from the properties of exponents. So if you can remember one, then you don't necessarily have to memorize the other one because they work hand in hand. It's just that it's in log form, not exponential form. So the first one says log a to the 1 is log base a of 1 equals 0. Right, so it's just saying that anything to the 0 power is 1. Right, it's something we talked about when we were talking about exponents. All right, the second one is log base a of a is 1. So it's saying that a to the first power is a. So another way to think about that is anytime we have a to the a log base a of a, that's always going to be 1. Okay, the second one, a to the log base a of m equals m. So a to the log base a, if these are the same base, they cancel out. Okay, and the next one says log base a of a to the r is equal to r. This one kind of follows the same thinking here, except for we have an exponent here of r. So that's just going to be r. Another way to think about it again is log base a of a cancels. So as long as we have the same base. The next one is product rule. So like we said in our exponential stuff, if we have, excuse me, the exponents with the same base, what we can do is add the exponents. Same idea here, it's just in log form. So log base a of m times n is equal to the log base a of m plus log base a of n. And then likewise the quotient rule is similar to the one in exponential form. This time we're saying log base a of m divided by n is equal to the log base a of m minus the log base a of n. So whatever your numerator is minus the denominator. Okay, and the last one, this one is pretty important in solving exponentials, and it allows us to get into our variable if our variable is in our exponent. So notice we have m to the r here. So log base a of m to the r is equal to, and what happens is we take the r and put it down in front. So notice now it's in front, r log base a of m. So it allows us to drop down any exponent we have on our base, on our value. Okay, so let's apply these. So simplify, remember we said if the base is the same as the log base and the exponent that they cancel, so this whole thing is equal to pi. Same thing here, log base is same as the value. That's going to be, oops, not pi. Getting caught up in pi. It's going to be equal to the exponent, which is negative square root 2. And then we said from last time, anytime we have ln e, those cancel. So this whole thing is just going to be kt. So on to the next page now. This one's going to be combining a few things. So, well, eventually combining a few things. We have this addition. We have the same base here. So what we're saying is we can combine them all into one log. So log base 6 of our values multiplied, right? So 9 times 4. So log base 6 of 9 times 4 is 36. Now we can go actually a step further because we can rewrite this as our base is 6. We're not sure what the exponent is, but then it's going to be equal to 36. So 6 to the what power is 36? X has got to be equal to 2. Okay, this one again, e and ln cancel out. So e to the ln 8, these cancel. We end up with 8. And then the last one is we're combining two things. So we're going to do like we did in the first problem on the top with that part, right? We have the same base. just 5. So we're going to write this as 1 log. So I'll write this 5, and we're going to say log base 5. And we're going to multiply the 6 and the 7. So we have 5 log base 5 of 6 times 7 is 42. And then notice we have the same base and the log base here. They cancel. So this whole thing is going to just be equal to 42. Okay, so that's it. Pretty quick. Please let me know if you have any questions next class. We can talk about them then. And again, good job today, guys.